of a ball in the neck of air chamber. Oscillations. Okay, oscillations of a ball which is in the neck of air chamber. It is a case of simple harmonic motion. And you know the characteristics of simple harmonic motion. The restoring force is proportional to displacement and it acts in opposite direction. Means restoring force and displacement, they are directed opposite to each other. They have a phase difference of 180 degree. Okay, then acceleration is also proportional to displacement, and acceleration and the displacement both are directed in opposite direction. Okay, then for simple harmonic motion, time period 2 pi under root m by k, frequency 1 over 2 pi k by m under root. K is spring factor and m is mass of the oscillator. Oscillator may be a, here it is a ball. Oscillator may be a ball of the simple pendulum. Oscillator may be a section of the liquid column. You have seen in YouTube oscillation of a liquid. Okay. Then you have also seen the oscillation of a bob in case of simple pendulum. Then you have seen the oscillation of a cylindrical piece which is dipped in liquid. Okay, then band force, and then that makes the cylinder moves up and down. Simple harmonically. There are different cases. You have seen the case of the body which is dropped in the tunnel which was dug along the diameter of earth. Okay, that also starts executing simple harmonic motion about the center of earth. So these cases you have already done. Now, case of a ball which have been put in the neck of air chamber, and you have to study its oscillations. Oscillation will be simple harmonically, and these are the characteristics: restoring force, proportional displacement, acceleration, proportional displacement. The time period will be this, frequency will be this. K is spring factor, m is the mass of oscillator. And this is the case when the oscillator is made to execute simple harmonic motion along a straight line. In case of simple pendulum, bob which was made to oscillate simple harmonic motion, that was kept very close to the ground, and there was not much amplitude of the bob.
सर मार्कर सिंक गिर रही है, ज़्यादा बढ़ गई.
चलो, okay. If you take angular oscillation, angular acceleration, not linear, then what will be the difference? In case of angular acceleration, there will be angular displacement. This is a linear displacement, there will be angular displacement. And then in case of restoring force, there will be restoring torque. Restoring torque. Okay. So this equation, first equation in case of angular acceleration, we'll take up that case also today. Angular oscillation. Angular oscillation. Angular oscillation, you have an example of balance wheel. In case of a watch, there is a balance wheel Okay, that is made to oscillate, and there is an angular displacement, and there is a torque which is responsible for angular acceleration and angular oscillation. Okay. So this formula will become torque will be minus c theta. Y is linear displacement, theta is angular displacement. Clear? And for rotation motion there is a torque. For linear motion there is a force. Clear? Then what will be the C? As you have K as supreme factor, here C will be the supreme factor. And here instead of mass of the oscillator you will take the moment of inertia. Moment of inertia of the oscillator. Then there will be angular acceleration. Angular acceleration. Instead of A, there will be alpha. Okay. So here you will have C over I into theta. You know, when you divide both sides by m, you get this relation. You divide both sides by m, then you get, and this is the acceleration according to second law of motion. And we replace k by m by omega square. Similarly, here instead of m, you have to divide by moment of inertia. So torque divided by moment of inertia will be minus c over I into theta. And this will give you angular acceleration. Torque upon moment of inertia. As force upon mass gives you linear acceleration. Clear? So here angular acceleration will be proportional to angular displacement. And formula for time period, if you compare this with this, it will be 2 pi under root m by k will be replaced by I by c. Mass has its analog moment of inertia and spring factor k has its analog this c. What is c?
Spring factor. Spring factor.
Spring factor. C actually is a restoring torque required for a unit angular displacement. If theta is 1, if you take theta 1 radian, then the C will be numerically equal to torque. From a formula you can identify, you can recognize a particular physical quantity. क्या हो सकती है? Okay. What was K? The K was F by Y. Restoring force per unit displacement. And what is C here? Tau by I. It is the restoring torque per unit angular. Restoring torque, यहाँ से देखो ना, यहाँ से. C will be theta torque by theta. Which means C, which is force constant, इसको torque constant बोलेंगे. Spring factor बोलते हैं इसको generally. Spring factor. It is the torque required for unit angular displacement. अगर आप इसका ऐसे यूनिट देखें, torque will be Newton meter and theta will be in radian. The SI unit of C, Newton meter over radian. Newton meter is also joule. Torque has the dimension of work. Newton into meter, force into displacement. So joule per radian or Newton meter per radian. That is the SI unit of C. Similarly, you can derive dimension formula for C. Okay? And I have told you, whenever you apply some constant and you want to identify the constant, then make the coefficients, all coefficients of this constant equal to 1, 1, 1, 1, 1. By chance here there is only one coefficient, theta. And if you take theta as 1 radian, then you will find C is equal to torque. Okay, torque is moment of a force, rotating ability of a force, force के घुमाने की ताकत. For rotation you need torque, for motion you need force. आप चलना चाहते हैं कि घूमना चाहते हैं? Okay, चलना और घूमना they are different things. चलना is linear motion, घूमना is rotation motion. Okay, so when I say the oscillator is oscillating simple harmonically along a straight line, then you have these formulas. When you make an oscillator having angular oscillation along a arc, ऐसे चलता है, okay, so then you need these formulas. Instead of force, there will be torque. Instead of linear displacement, there will be angular displacement. Okay, so instead of K, you will have another constant C. As K was force per unit displacement, the force per unit linear displacement. This is torque per unit angular displacement. Here unit will be Newton per meter. Newton per meter. Here torque per unit angular displacement. The torque has SI in Newton meter and the theta will be taken in radian. So we will switch over to these formulas. And as far as the formula for time period is concerned, you will have analog. Analog of mass is I, moment of inertia. Analog of K is C. When oscillator is having angular oscillation, the expression for the time period will be 2 pi under root I by C. And then frequency, reciprocal of this 1 over 2 pi C by I under root. So, to discuss any case of simple harmonic motion, first of all you have to see whether the oscillator is executing simple harmonic motion linearly along a straight line or along the arc of a circle. Okay, the body is made to oscillate along the arc. ये तो rotation motion, circular motion हो गई ना. तो इसमें you need these formulas. The example of this angular acceleration case is the balance wheel. What is that? You have here there is a spring over here and there is a axle. Okay, axle, and here there are and you have a rigid support. Okay, here diamond points are there. Here also. Means the axle is this axle, which you call it as the axis of rotation, about which rotation will be taking place. Rotation will be of the wheel. Okay, there will be a spring over here. This spring will provide the restoring torque. This spring. Okay, and oscillation of this wheel. Here also you have आपने वॉच देखी होगी. वॉच में ये ऐसे गोल्डन सा ही ऐसे व्हील होता है, बीच में स्प्रिंग होता है, ऐसे ऐसे ऑसिलेट करता है. Angular oscillations are produced. And the oscillation of the wheel, this is balance wheel, they will control the movement of hands of the watch. Second hand, minute hand, hour hand. There are 3 hands in a watch. उनकी जो movement होगी will be controlled by the movement of the balance wheel. And what for the spring is, will provide restoring torque. Okay. Without restoring force, body cannot execute SHM. That restoring force has to be proportional to displacement. And here, without torque, body cannot have angular oscillations. And this is the restoring torque. Okay. An angular oscillation whenever there is an angular displacement. इतने एंगल से घुमाया इसको. ओके. ये जो एक्सेल है, दिस इज एक्सेल, axis of rotation. This is the axis about which this wheel will rotate and the spring will rotate. Spring will provide you the torque, restoring torque, whereas wheel will control the movement of the hands of the watch. Now this is a case when you have angular oscillations and you need these formulas for time period, for frequency, and for the testing whether this is executing angular simple harmonic motion or not. Clear? The role of everything has been told to you. Diamond points here and here. Between these two diamond points, as you have a rigid support, ऐसे spring होता है, mass is attached, तो ये फ्री एंड पे मास अटैच कर दिया और दूसरा एंड को रिजिड कर दिया. तो सिमिलरली ये जो डायमंड पॉइंट्स हैं, ये एक्सिस है, एक्सल है, एंड दिस इज बिटवीन द टू डायमंड पॉइंट्स. देन हियर एट द सेंटर देयर इज अ स्प्रिंग एंड देन देयर इज अ बैलेंस व्हील. द आउटर पार्ट इज मेड ऑफ these are made of two different metals. Why? During summer, during winter, whenever there is a change in temperature, there shouldn't be any expansion. If there is an expansion in this, that will be compensated by the other. Okay? बाहर स्टील का, अंदर ब्रास का. दो डिफरेंट इसलिए लिए गए हैं कि अगर टेम्परेचर चेंज के कारण कोई एक्सपेंशन होती है तो एक्सपेंशन का इसके ऊपर कोई इफेक्ट ना पड़े, एक दूसरे को कंपनसेट कर दे. एक एक्सपेंड करता है, दूसरा कंडक्ट करेगा अपोजिट डायरेक्शन में, तो ओवरऑल नेट एक्सपेंशन विल बी जीरो. क्लियर? तो इसके आप ये फॉर्मूला लगा दो. आई मोमेंट ऑफ इनर्शिया है, मोमेंट ऑफ इनर्शिया ऑफ जिसने रोटेट करना है, मोमेंट ऑफ इनर्शिया ऑफ द सिस्टम, मोमेंट ऑफ इनर्शिया ऑफ द ऑसिलेटर. क्लियर? तो ये जो ये व्हील के ये पार्ट्स हैं, इससे अटैच है, ये इससे अटैच है. ओके, ये इससे अटैच है, फिक्स है. ये वो पूरा सिलेक्ट करेगा. क्लियर? जब ये ऑसिलेट करेगा, there will be angular displacement in the spring about this axle. For example, let us take a wire and there is a sphere over here. Okay? तो इसमें ट्विस्ट पैदा करो, इसको घुमाओ, चलाना नहीं, घुमाना है, इसको रोटेट करना है. Let us say on rotation there is an angular displacement of 45 degree. इसको हमने 45 डिग्री से टर्न कर दिया. ओके, ये जो सस्पेंशन वायर है, जब वो बाल को ट्विस्ट करेंगे, इसमें रोटेशन पैदा होगी ना. इसको पकड़ के ऐसे घुमाएंगे, जैसे आपका ये हैंड है, ठीक है ना. यहाँ से अगर आप इसको घुमाते हैं, घूम रहे ना, कितने एंगल से घुमाया, मतलब इस पोजीशन से आप इस पोजीशन में ले गए, तो फाइंड आउट हाउ मच एंगल थ्रू व्हिच इट हैज बीन रोटेटेड, है ना. तो यहाँ एंगुलर डिस्प्लेसमेंट लेट अस से 45 डिग्री व्हिच विल बी π/4 रेडियन. And when this is rotated through 45 degree or π/4 radian, torque, let us say of 6 Newton meter is produced. Okay, torque of this is produced. Find out the time period of oscillation of angular oscillation of this. And time period formula is 2 pi I by C. I is not given. Let us say I is value of I. Can you calculate? You have this and this, and this you have to, you can find out C. With the help of this formula, you are given angular displacement theta and torque. That means these two things will help you to find out C. What will be C? C will be
24 by 5.
how much? 6 divided by pi by 4.
24
That
by
is
5.
24 by pi. And what are the unit of C? Newton meter per radian. Okay? If any physical quantity has a dimension, you must mention the unit.
अरे तो 5 की वैल्यू नहीं डालेंगे
3.14, 22/7 you can put. तो इसका यूनिट आपको पता लग गया, न्यूटन मीटर बाय रेडियन. Clear?
Yes, sir.
You are asked to find out time period. 2 pi you know. Moment of inertia is not given. But C you can find out. So C is this much. And without I you cannot calculate T. So you must be given I also. So let us suppose I be there after. I is given in the problem. Let us say it is 36 kg meter square. Moment of inertia, m into r square, unit will be kg meter square in SI system. Now these items are sufficient to calculate T, or frequency. Got my point? So, first of all, you have to see, when you are given a new case, you have to see whether it is a case of linear oscillation or angular oscillation. Okay? So you have to differentiate. One example of angular oscillation I have told, the wheel of a watch. The different components and the role of different components, and then problem based upon that. Clear? Now another case is in front of you, and again you have to see whether oscillation will be linear or angular. You have already done 4-5 cases of linear oscillations. इसको देखना. This is the neck of a chamber. This is neck. Air chamber may have any shape. There may be the round part of this also. जैसे फ्लास्क होता है, inside air, then long neck. So this is air chamber. It contains air, and the parameters of air are pressure P, volume V, temperature T. System is air. Then there is a ball. This is a ball in the neck. The ball, let us say, has a mass m. Clear? Then this neck has area of cross section. of neck of air chamber. Clear? M mass of ball. So in this case, oscillation of a ball means ball will be made to execute simple harmonic motion. We have to see linear or angular. Which formula to be made use of. So this is the ball and system is in equilibrium. There is no movement in the ball. Now how to make the ball oscillate simple harmonically. Second diagram. Ball previously was in this position. This position is A. Ball is depressed, pressed downward to this position B. This was A, this is B. It has been depressed through a displacement Y from this position to this position, from A to B. Then what will happen to these parameters? When you apply some external force or some pressure to make this ball get depressed inside the neck in the downward direction, what will happen to the pressure of the air chamber?
It will increase.
It will increase.
Temperature will increase also.
Okay. Then how about volume?
It will decrease.
Volume will decrease. How about temperature?
It will increase. It will increase.
You cannot say about change in temperature.
So but
If this is a slow process, isothermal process, no change in temperature. And if there is a sudden depression, okay, साइकिल में हवा भरते हैं, पंप है, सिलेंडर है, पिस्टन रॉड है, धीरे धीरे स्टॉप लगाओ, सारा दिन में एक स्टॉप, टेम्परेचर नहीं चेंज होगा. Air will go inside the tube. There will be no change in the temperature. It's an isothermal process. It is a slow process.
yes.
And quickly, if you do this exercise,
टेम्परेचर इंक्रीज हो जाता है.
एकदम पंप गर्म हो जाता है. Work can be converted into heat. It becomes adiabatic process. You have to see, unless it is given, okay, this is pressed downward slowly or quickly. Means this is a case of isothermal process or adiabatic. And if you are given that it is isothermal, then temperature will have to be constant. And if it is adiabatic, temperature will increase.
तो वैसे जैसे मतलब एग्जाम में ऐसे बताया होगा क्वेश्चन में कि ये
There are two options. Okay, temperature may change, may not change.
नहीं सर जैसे क्वेश्चन में मतलब दे देते हैं कि ये जो बॉल
It will be mentioned. This ball is depressed isothermally. The temperature will remain same. If it is compressed adiabatically, then naturally temperature will increase. Unless and until it is given which process, you cannot talk about temperature. Remember this thing. Okay? Achha, when you have applied this external pressure or extra force from outside agency, then these changes take place. Okay? And there is a volumetric strain. There is, in this case, volumetric strain. What is that? Equal to minus V by V. Why minus? On increase of pressure, there is a decrease in volume. So we attach minus on. This is volumetric strain. Now if you take K as the bulk modulus of elasticity. You know elasticity and the different coefficient of elasticity, Young's modulus, bulk modulus, modulus of rigidity, depending upon which type of strain is produced. This is a case of volumetric strain, and the coefficient of elasticity will be bulk modulus of elasticity. Got my point? And you know the expression for bulk modulus of elasticity, it is stress by volumetric strain. Stress is force of an area. This force has been applied on a area cross section of the neck. यहाँ लगाया गया ये extra force, extra pressure. Clear? So what will the expression for F? F will be from this. Get the value of F. F will be minus V upon E तक चला जाएगा ना. A भी नीचे आएगा. This will be K A minus K A minus B upon V.
सर
What?
ए नीचे नहीं है.
क्यों? यहाँ A नीचे आएगा ना, then it will be transferred to this side.
Yes.
This can be written like this also.
Yes,
F
sir, yes.
over minus V by V into A. Okay, you want F, the denominator should be shifted to this side. Clear? So what is this small v? Small v is change in volume. And here there is a decrease in volume. The change in volume, that will be A into Y. When bar is pressed from this position to this position, whatever air was contained in this portion of height Y has entered into the lower part of the air chamber, and it causes the decrease in volume. Okay, and this neck is cylindrical and volume is cross section area into height. Okay, the neck is uniform. It has uniform area everywhere, right from top to this portion. So change in area, change in volume will be easy to able. Then you can replace this V by this. Then this force will become minus K A square minus K A. This is A into V. Then you have Y over here and then V. Okay. Now this force is proportional to displacement. It acts in a direction opposite to displacement, and clearly it is a case of simple harmonic motion. And this ball is having only linear displacement. It is a case of linear oscillation, not angular oscillation. Got my point? So you have to differentiate whether the oscillator is executing linear oscillation or angular oscillations. Whether the oscillator is moving up and down along a straight line or moving here and there along an arc. In case of simple pendulum, we keep the amplitude small so that the path along with that palm move is almost straight. उसको बहुत ज़्यादा ऊपर नहीं उठाते कि वो एंगुलर हो गया. ओके, इसलिए वहाँ assumption लेते हैं. So here, because restoring force, क्योंकि एक्स्ट्रा प्रेशर पैदा हो गया अंदर, the tendency of air will be to move from high pressure to low pressure. Outside pressure low है. Clear? तो जब आप इसको रिलीज कर देंगे, restoring force आएगा and it will take this ball back to A, and this ball will overshoot this position, will go to this position. ये यहाँ आ जाएगी. From its mean, this will act as a mean position. About A it will go down and up. It will execute simple harmonic motion about the point A. ये नीचे भी जाएगी, जितना नीचे जाती है उतना ऊपर जाएगी, क्योंकि simple harmonic motion means the limits are same. Got my point? अच्छा, जब we will take this position, then what will happen? There will be decrease in pressure inside the air chamber, increase in volume. Nothing can be said about temperature. When outside pressure becomes more than the inside pressure, then again this ball will be pressed from up to downward direction. and that way it will start executing simple harmonic motion, and this is a case of linear oscillation. Therefore, what will be the acceleration? Acceleration is force upon mass. So you divide both sides by m. It will be minus k a square m into v into y. Again, acceleration is proportional to displacement and directed opposite to displacement. Clear, it is a case of simple harmonic motion. Okay. Can you tell me what is the spring factor in this case?
K.
K is bulk modulus. Spring factor means when you say F is equal to minus ky, this is the spring factor, the coefficient of y.
minus ka square upon b.
Here, the coefficient of y in the expression for storing force.
Minus.
Coefficient of y in the expression for storing force is force constant. Okay, this is force constant. This is bulk modulus of velocity. They are different. Don't get confused. Now, in this expression for storing force, what is the coefficient of displacement? Is this.
Yes.
Therefore, in this case, force constant is K A square by B. Forget minus sign. Minus sign only indicates that the storing force and displacement they are directed opposite each other. And this force constant has no sign. It is not a vector quantity. It is a constant. It will never be negative. It's always positive. Okay? So, if you want to find out the force constant different cases of simple harmonic motion, so you have to take the expression for the storing force, and whatever is the coefficient of displacement, that is force constant. And don't get confused with bulk modulus of velocity, though they have the same symbol. In order to get rid of this confusion, to take bulk modulus by B. Okay, bulk modulus of velocity denoted by B.
Yes, sir.
Then there will be no confusion. Clear?
Yes, sir.
Otherwise you will get confused. So, to go for time period, it is 2 pi m by k. That means 2 pi under root m by k. This is k.
Yes, sir.
Force constant. Not bulk modulus, force constant. ये है. तो डिवाइड करेंगे तो b will go up and k a square will go down. Then this can be written like this also. 2 pi under root mv over k when you take a outside. Clear?
Yes.
Expression for the time period of oscillation of ball, which was in the neck of the air chamber.
Yes, sir.
So, now there are two options. P is equal to 2 pi over a under root mv by k. Now the question is, this phenomena is isothermal or adiabatic. If this ball is displaced from its mean position slowly, so that there is no change in temperature, that means that this process will be taken as isothermal. In isothermal process, temperature means constant, and for isothermal process, for isothermal activity, the bulk modulus is always equal to pressure, and time period will become 2 pi by a under root mv by p, case 1. And if you take This has a adiabatic process, means ball is depressed quickly. Then for adiabatic process, bulk modulus is gamma time pressure. There you know gamma ratio of Cp by Cv, and for air its value is 1.4 for air. We are dealing with air chamber. That means chamber contains air. It may contain mixture of gases also. Okay, or a particular gas. For that, it will be given the value of this gamma. The gas is monatomic, diatomic, triatomic, polyatomic. The K is different. Okay, and this gamma is different. Gamma is, 1 plus 2 by F. F is degree of freedom. Degree of freedom for monatomic gas and for diatomic gas different. When degree of freedom are different for different type of gases, then gamma will be different. Value of gamma will be different. But especially, as I said, this is an air chamber. That means the chamber contains air. And for air, we know the value of gamma 1.4. Clear? So if this process is adiabatic process, then bulk modulus of velocity will be gamma time v. Then time period of execution of this ball will be 2 pi a under root mv by gamma p. Clear? Achha, these relations have been derived on the basis of some assumption. Can you think of those assumptions? हमने क्या assume किया होगा? एक्सप्रेशन टाइम पीरियड का ये आए, अगर बार को वेरी स्लोली कंप्रेस किया गया है या क्विकली प्रेस किया गया तो ये आए. ये फार्मूले भी ट्रू है अंडर सम कंडीशंस. वो क्या? कि there is no friction between ball and the surface of the neck of the air chamber. बाल ने ऊपर नीचे जाना ना, oscillate करना, simple harmonically. And if there will be a friction between the surface of ball and surface of the neck of the air chamber, then oscillation may not be simple harmonic. Due to friction, it may cause loss of energy and the limits may not be same. जितना वो नीचे गई उतना ऊपर नहीं जा सकती, एनर्जी लॉस हो जाएगा. ओके, तो ये it will become a case of harmonic motion but not simple harmonic motion. For simple harmonic motion, limits have to be same. So we have supposed that there is no friction between the ball and the surface of the neck of the air chamber, number one. Number two, when this ball will be executing simple harmonic motion, it may suffer some loss due to air friction. ये एयर भी तो इसको रोकेगी नीचे, पता, आउटसाइड एयर भी तो रोकेगी इसकी मूवमेंट को. wherever there is a motion, there is a friction. Air friction will be there. वो तो फ्रिक्शन में भी है between the surface of ball and surface of neck of the air chamber. और अब ये ball is executing simple harmonic motion in the neck of air chamber. It is disturbing air also. It is causing variation in the volume of air or the pressure of air. May cause variation in the temperature also. Okay? तो जब किसी सिस्टम में चेंज आता है तो अपोजिशन होती है. वॉल्यूम डिक्रीज करना, इंक्रीज करना, प्रेशर में वेरिएशन लाना, टेम्परेचर में वेरिएशन लाना, एयर को अच्छा नहीं लगेगा. तो बाल को अपोज कर सकती है. बाल क्यों डिस्टर्ब कर रही है मुझे बार बार? ओके, आपकी यहाँ क्लास लगी, बार बार कोई दरवाज़ा नॉक करे तो आपको गुस्सा आएगा ना? क्यों बार बार फोन आ जाए, आप सुनना नहीं चाहते, फिर आप इरिटेट हो जाएंगे, अपोज करेंगे नहीं, बंद करो इसको. क्यों बार बार ऐसा? यू आर बीइंग डिस्टर्ब्ड. The air is being disturbed by the movement of this ball in the neck of the cylinder. So we have to ignore the friction caused by air and friction caused by the two surfaces, surface of ball and surface of neck in contact. इससे जो फ्रिक्शन होगा वो भी हमने इग्नोर किया.